And we're back with another episode of the New Stack Agents, our show about all things AI and agents. And with me, as always, Alex Williams, who's in fine form today, I have to say. So I'm looking forward to our conversation.
You know, I changed out of my KEXP sweatshirt just for this special occasion. I love that radio station, by the way. Anyone out there is a KEXP fan, let me know.
Where is KEXP?
They're out of Seattle. They're an independent music station that's just one of the all-time best, in my view.
Very, very nice.
Anyway, so I'm a supporter. So support your local independent radio.
There you go. And our podcast, obviously. So, like, subscribe, you know what to do. And with us today is Pat Casey, CTO of ServiceNow and co-founder as well, I think officially, right? So.
Yeah, it's complicated. I was the second human being to work on the code. The first human being was Fred Luddy, but in the world of technology, there's the founder and a founder. Fred is the founder and has a Gulfstream 650 and once owned a tennis team. I didn't even know you could buy a tennis team. I do not own any aircraft. That's what being a founder means. But I'm still working in a great technology company and a great job. So there's lots of benefits.
Do you mind if I just ask about that day when you put your hand on the code for the first time?
Yeah. So I knew Fred from a previous life. He and I had worked together at a previous company we worked at. And I ran into him literally on the street because we lived in the same town. I almost literally hit him. I had a convertible at the time. He was distracted and walked into the road, and I pulled up really quickly and almost hit him and honked at him, and I flipped him off. It was not the best move. And then I recognized him, and he's like, "Pat, Fred." We stopped traffic for a little while. And long story short, he told me, hey, he started a new company. He had some interesting stuff to show me. Did I want to come by and see the code? He had a little office like upstairs from like a restaurant. And I remember I went up there and he sat me down, and I'll be honest, I didn't get it because it was the early days of ServiceNow, and he was pitching his concept of a platform that regular people could use to build business apps. Like that was always his concept. And I sat down and I'm like, yeah, but like they're really simple business apps, and like it's kind of limited in your configurability. Like you can't like do full, byte perfect screen layouts. For some of the competitors I knew, you could do that. You got a form designer and you put the button just here. Fred's world, like the buttons went on top and the form went in the middle, and you had limited configurability options. And his premise was, yeah, it's less fully configurable, but it's fully deployed on the internet. It's a browser-based app, which in 2004 was like super new and super exciting. And he's also like, yeah, but it's so much easier. Like, who cares that this is technically possible with these alternative tools? Almost no one can do it. With my approach, this is Fred talking, almost anyone can do it. And I was in that group of people who was really good at working with traditional tools. So I'm like, man, my skill is amazing. And like, this is the way it has to be done. But I was wrong, fundamentally, like I still went to work with Fred. We worked on that. I remember going to the first couple of customer meetings, and those were super exciting because like the customer's eyes light up. And because suddenly they could personally do something that they couldn't do before, something which was impossible for them. They had to ask an expert or a third party to do it. They could do themselves. And like that sense of empowerment those early customers had when they just use that platform, it's super exciting as the developer because you want people to use your code. Like that's why you go into this. I want my art on your refrigerator. But it was also like the early fuel for the company because like you have happy customers, they tell their friends and they pay for the software. And like that was the secret sauce Fred had. It was like regular people could do meaningful stuff on it. Lots of benefits as well. Good product, good this, good the other thing. But like for one thing, I would point it at that. So.
Gosh, I have so many questions, but Frederick, what's on your mind?
Actually, while you were saying that, I was thinking, like, what's the last code you've written that's part of the platform? So.
Well, I'm a CTO now. So like these days I do not directly, my hands are on keyboards, but usually I'm writing email or we're actually a team shop. So it's more likely to be Teams than Slacks. But the last code was probably some stuff in our cache manager of all things. It was it's super quirky code. It's awkward to get right, because long story short, it's awkward to get right, but it's incredibly performance critical. So it's one of the last pieces of code where I felt like it was a small enough ball of code that I could like make diffs and not be afraid of breaking a bunch of stuff. But it was meaningfully complex enough that like I was actually adding value by writing code. Because at some point you're a senior leader and it's a big organization. I write a bunch of code. It's actually a tax on the organization because they're like, Pat, you don't actually know what we're doing anymore. And you're just, scratching your own subjective itch. The cache manager, I felt like that was something that I can write a singleton cache because we need to cache singletons in a lot of frequency. And as you can tell, my background is very much hands on the keyboard engineering. So I warned the host on this before. I will go like super deep if given the excuse. So obviously pull me up if I'm getting subterranean.
Will do. Do you miss it though? Sometimes, like right now, when I talk to a lot of leaders, they're telling me, "Oh, vibe coding has given me another avenue to just get back and write more code and actually get something done quickly on the weekend."
That's a complicated question. So, do I miss it? Yes. I also do wonder, and I don't have an answer for this. I'm older than I was. Like when I was in my 20s or my 30s. I could get into a very strong, like, I guess you call it a flow state where you're just writing the code and like I would forget to eat. I'd forget to go to the bathroom and like 8 hours later it'd be dark out and I'd be starving and really have to go to the head. And I'd finally get the algorithm working. And like that, like loop, you get some sort of like a dopamine hit on. It's incredibly satisfying to work a hard problem, go all in, get your whole brain focused on it, and see it through and get to the end and then commit. That loop was incredibly rewarding for me. Like I loved doing that. And I do miss that 100%. I don't take any intellectual pleasure on writing code for its own sake though. Like for me, there's got to be a customer problem I'm solving or a business. Why am I doing this? There's got to be a reason. So just like, I don't know, vibe coding a better hash table is not interesting to me. Like plus it's pretty solved. There's only so many ways you can hash things.
So I have a question for you then.
Yeah.
When you talk to engineers and developers out there, you're talking about agentic AI, for example, what's the dopamine effect that they're talking about?
I think it depends on where in the stack you are. So if you're one of the people who builds fundamental models, your dopamine hit is you wrote a cool model. And people like your model, and you go to like model gallery and people are downloading APRL or StarCoder and you're like, that's my model. People are using that. It's not the short-term dopamine hit, but it's that medium term, like the work I did is meaningfully impacting other human beings in a positive way. They're getting value out of the stuff I did. I've added to humanity, for lack of a better word. If you're doing more like, hey, look, I'm doing feature development, it is, I think, and I see this with some of my colleagues, it's the ability to take a concept to like that first iteration very quickly and take it to someone else and say, is this what you were thinking? Or how does this work? Does this seem like the right approach? And like that might have taken you a week in a pre-AI world. If you've got the right tools and you kind of know how to prompt, and especially if you pick problem spaces which map well onto what these AI code assistants can do right now, you can get from concept to first iteration in a fraction of the time. Right. There may still be polishing you want to do before you get it like in customers' hands, but you can get that first version out quickly and you can iterate much faster than you could in the past. And that is, I do think it's a strong dopamine hit. I'll add one piece, which is very back level. Like it is, sure I'm looking for here. The lower you are in the stack, I think the different part of your brain it tickles. I think there's overlapping, but like writing assembler just feels different than writing C, feels different than writing Java or something else. Vibe coding or working in the prompt level, it does feel like it's a level above. So at some level, it's a better because I can get more done faster. At another level, is a part of my brain that really does want to do, pushes and pops and, call the adder that doesn't get scratched the same way when I'm vibe coding something. The flip side is you can also just, you follow it up and you're like, hey, this is pretty good code, but I can make it better with my own hands. And a lot of people still do. Most people do, in my experience.
What is that like inside of the company right now? Because there are enterprises where there's almost a mandate to use coding assistants, be that Cloud Code or Copilot. What's that like in ServiceNow? What's your take on that?
We're not mandating, but we are investing pretty heavily. So we were big users of like sort of the first generation of coding assistants. We have our own. Like if you're writing ServiceNow code in ServiceNow, there's a bunch of AI stuff like directly in there. And a lot of our internal engineers write code the same way our customers do. They're literally using our in-house stuff. For the platform development or parts application development, where we're not writing within our own metadata framework, we were Copilot users, GitHub Copilot. Get decent results on it. It was a good product. We made a big investment actually in Windsurf recently.
You did?
Oh yeah.
Interesting.
We did a big evaluation. We looked at them. We looked at several competitors. They won pretty hands down. I deployed it across about 7,000 engineers. And then we did a big old training. And then we even measured like before and after productivity. It's not a true, if I was truly a scientist, I would have randomly assigned half of my engineers Windsurf and then prevented the other half from using it, and like productivity of the two groups. Real world, I gave it to everybody. And what I did is I compared the first release they did post training with the last release they did before training and said, like, is there more stories per unit time per engineer? There are about 10% more, which is similar to what Google reported. Like Google said about 10%. What we're seeing is consistent with that. To your question, though, it's not a mandate. What I told the team was, hey, I'm going to invest in this tool here. It's my credit card. It's the company's credit card. I'm going to train you on it because I don't want like there to be this sense that like you don't know how to use it. I'm going to measure your output. Like if you're producing great code at high volume and high quality, I don't care if you use the tool or not. Like maybe you're that weird human being who's just such an amazing developer that this is going to slow you down. Okay. Like to me, the tool is a means to an end. The business outcome I'm solving for is, are you writing good code for our customers at a good rate? That's what we measure. I don't care about the tool use per se. I will say, I mean, I sincerely believe you're going to be a better developer with modern tools. Like no one seriously doubts that like a debugger makes you a better programmer or an IDE.
Right.
Same thing with AI tools. Like they just help. And I think it's almost table stakes to be an engineer these days, just know how to use these tools.
So I have a question about Windsurf, which is a newer tool for developers.
Yep.
And so you're deploying it, to a group of engineers at ServiceNow. We talked last week about how enterprises are starting to, excuse me. Enterprises are starting to look at AI tools. What are you seeing from the customers out there? Are they deploying Windsurf? Are they doing similar kind of work? Are they not?
I mean, it's plead slight ignorance, but I'm going to talk about what I do know. I actually don't know, apart from people who've talked to me, like my peers in the industry, people are like, hey, I'm using Cursor, I'm using Windsurf, I haven't done anything yet. You get some of those conversations. And I definitely do hear, the two I hear the most are probably, well, three, Cursor, Windsurf, and you still see a bunch of people on GitHub Copilot, and that keeps evolving too. I can't tell you based on any kind of empirical data what the distribution there is.
Sure, of course.
And it's changing super fast. More narrowly in like my customer base, like a very common thing they do is they literally use the products we sell them because they have their own, development environment. If you're going to build like agentic solutions or AI solutions in ServiceNow, there's like a ServiceNow tool suite you use. There's exceptions. You can put third-party stuff in there to do some stuff if you want to. In that case, yeah, we know broadly what the customers do with it, but we're not a consumer company. So like, I don't look at my customers' data. Right. You can authorize me to look in some case if you really want me to, but like generally speaking, I know what I sold you and I know some high level things. Like I know how much storage you're using and how many transactions you run, but like, I don't know what individual workflows you're executing or what your business cases are.
For the developers inside the ServiceNow, though, one thing I've come across quite regularly is just developers who really don't want to use these tools either, right? Is that something you've come across?
In terms of not wanting to use the more modern tools?
Yeah, and LLMs and just code generated by an LLM.
I have seen it. Maybe less so than I would have expected. I think my experience has been engineers tend to be technophiles. Like we like technology, and most good engineers are sort of, I'd say we're enlightened lazy. Like we want to solve for our own productivity. And I think people are smart enough to realize that actually these tools, they actually help. Where I've seen pushback is like, I'll call them silly mandates, like thou must generate code with this tool. It's like the old IBM mandate. You must have a certain number of lines of comments in your code, and people would like comment in a recipe for cookies or something just to be passive aggressive. I've seen that. There definitely is somewhere out there's a human being who's like, man, I hate this stuff. Like, I just don't, I feel like this is my special sauce. Like I love coding with my own two hands, but there are people who still do celestial navigation crossing the ocean. They don't use GPS. Like it is a hard math problem.
Good for them.
Yeah. I'd rather use GPS or GLONASS or whatever. So
I wanted to follow up on that. Do you see the people who are responsible for deployment and management of at-scale technologies having a more conservative viewpoint about AI? And what do they say to you? Or is that not really valid at all?
That one's a mix. So there's, if I go to most customers, and I won't name anyone by name, but just in general, I talk to a fair number of customers, and we're a medium-sized shop ourselves, 25,000, medium-sized company. I guess large, but we're not uber large. We're not Walmart large.
Definition of medium is.
Yeah, that's our size point.
Right.
There definitely are parts of the corporate world who are like, man, this is kind of scary stuff. Like people got like their own personal credit card out, and they bought, ChatGPT, and they're putting our policy documents in there and asking GPT to summarize it. And there's information leak risk. And like the compliance and the security people, they worry about that. And to some extent, like that's what they're paid to worry about. It's not always a perfectly fallacious worry. There's the parallel side of it, though, where every corporate entity in the world is under pressure to do more with less resource. Like let's do it. And so the talk track in the industry is like, hey, AI's got to help people be more productive. So like, what's the productivity gain? Like, are you using the right tools? Can more tools help you get more stuff done? So there's this push as well to like get tools rolled out, and then to, hopefully measure some meaningful business outcome on the positive side. It's like, hey, we got 10% more stories done, which is great. In the case of ServiceNow, like my backlog of work, I don't have people to put on is so high, but 10% more stories just means that we just get 10% more stuff done. It doesn't turn into like, oh, we're going to reallocate engineers to different parts of the company. But like the productivity benefit is real. Getting more stuff done with the same people that's how economies grow. That's how society gets more productive.
Which is interesting because we've also seen studies that said, well, developers are overestimating how much these tools are helping them, right? And it sounds like that's really not what you're experiencing.
Well, yes and no. Like so when this stuff first hit, we call it 18 months ago, call it the ChatGPT, the Sputnik moment, when it rolled out and people had this thing's Turing passing. We did some internal POVs with at the time seemed very sophisticated, but in hindsight, it was a really primitive code generation tool. And engineers are like, yeah, this can make me 30% more productive or 40. And I had very senior engineers who were very smart human beings with decades of experience, just very passionate that this was going to be game changing for them. And then we rolled out like the first generation tools, like I mentioned, like Copilot, and like maybe 3%, maybe 4%, a good day. Lines of code written to different metric, but just more stories. And then we rolled out Windsurf, which is a much more sophisticated tool. And so call it 10%, maybe a little more, which is great. Like when you got 7,000 engineers, 10% more productive is like hiring 700 more people. That's like really great. But that's still a third of what the estimates were for that primitive tool 2 years ago. So yeah, I do think people's subjective sense of the benefit is too high. And this is not based on some deep psychological study. I think a lot of engineers like overestimate the proportion of their time they spend actually coding, if that makes any sense. Like in the corporate world, even my ICs who code for a living probably spend less than half of their time coding, and they're in like don't bribe people training, or they're in a meeting, or they're talking to a customer. I mean, these are all great things to do. You shouldn't bribe people, and I should make sure I tell you not to do that. And talking to customers is always good. But like this idea of it, like you're spending 8 hours a day, 5 days a week coding as an engineer, it's not that true. In a real corporate coding job, there's a lot of other things you do in addition to writing code. And the AI is not necessarily going to make that any more productive, although it might, depends on what your secondary task is.
Can we turn the conversation a bit, Frederick, if you don't mind? I'm curious about agentic AI, though, in this context, because you all have invested deeply in agentic AI, and a lot of the promise about agentic AI is about autonomy. And you all have like a more of a controlled version of autonomy from what I've read. And I'm curious about that approach and how you're getting it to be adopted internally, because it goes back to the, to the stories like, drink your own champagne type of thing. How's that emerging inside ServiceNow? Like, can you talk about particulars about how, for instance, your teams are using autonomous agent?
Yeah. So we have an internal program called Now on Now, which you might imagine it's like we are using ServiceNow technology inside of ServiceNow. And that runs the gambit from like we use our own ITSM solutions, we use our own CMDB. And these days, it also means we use our own, AI and agentic tools. And I'll pick on two that are actually on our support organization because they report to me. So I'm like super close to the use cases. One of the use cases is just straight up like question and answer. Like you go to my support portal and you type in, I can't figure out how to write a business rule, help. Traditionally, what it did, it searched the knowledge base and it gave you a bunch of links. Click here for a knowledge base article. Think like Google search. These days, it doesn't do that. It does do that, but what it also does is it tries to find the most relevant articles and directly answer your question. So it's like, hey, start with this and do this. It gives you an answer, gives you a little reference, and then at the bottom, it's like, if you want to read the primary sources, here it is. Like that direct Q&A. Not super sophisticated. Like this is like, we had this stuff in the market for like a year, but very valuable. Like it deflects a lot more tickets. It gets customers their answers without having to go through the ticket loop, because the ticket loop slows the customers down and it drives my guys crazy because it takes time for them. So if I can do that completely autonomously, just by giving your answer with an AI agent, the ticket loop never happens, which is best for the customer, best for the outcome. On the backside, like we actually have agents that do things like research tickets. So like you open a case and it says, hey, look, I can't figure out why my emails didn't go out last night. Okay, maybe you misconfigured your instance. Maybe there was a global email outage in our email infrastructure. Maybe you used Gmail and Gmail had a 4-hour outage and just everything queued up. I don't know. But it's knowable. Like you can look into logs, you can look in some publicly available information, you can maybe look at like down detector, you can collect some information to help debug that issue. So we have an agent where like you basically tell it, hey, try and figure this out. I'm grossly oversimplifying. And it goes out and it talks to some third-party systems, it looks at the logs, it summarizes them, and then it comes out and it puts a dump of information into the case. Basically says, hey, look, we researched this for you. This is what we think is going on. We think it's because there was a Gmail outage for 2 hours last night and it probably impacted the customer. And then as a human being, you can look at that and agree, disagree, do some more research. But that researching stuff all happens autonomously. That ticket gets opened, the research agent kicks off, does the research. By the time a human being looks at it, it's done. Like there's just extra enrichment that's been done by the agents in there. The next step of that, which isn't live yet, so I don't want to oversell it, there's about 15% of the cases where like we're pretty darn confident the thing the research agent came up with is right. Like we're so confident we don't need a human to review it, and we can usually identify those. We want to close that loop and just have like, okay, the research agent researched it. Now we're gonna have the closure agent come in and like tell the customer, hey, this is the answer. Please approve us closing the ticket out. And if you don't agree, like put the comment in here and we'll reopen it and keep working for you. But that closed loop, you know, we do round numbers, 400,000 cases a quarter, I think, about 100,000 a month, if I got my numbers right. 15% of that's 15,000 cases, like automatically managed through that. The benefits are real, and you don't have to imagine it's going to do 100% of the work ever to get a benefit. 15% of a big number is still a big number.
One thing while you were saying that, I was thinking, what was it like building up the infrastructure? And it's a broad question, but building up the infrastructure to run all of this, because it's very different from how systems used to run just a few years ago, right?
Yeah. I'll give the infrastructure answer, and then you can ask me if you're hoping a layer up from that.
Go as deep as
you like, please.
So we're probably the last SaaS company that was built on physical infrastructure. Most of the people who were born after us were sort of born in hyperscaler world.
Right.
So if you look at my workload today, I'd say upwards of 90% of it runs on like physical gear. Like I buy servers from a vendor and I put it in a rack and I, cable it up in a data center, and there's a cage and all of that fun stuff. Our strategic plan, I think by 2030, we expect to be at 50% hyperscale or 50% public infra. Like a balance seems like a good place to be. But right now we're weighted toward physical infra. So if you look at the Gen AI revolution when it came out, it's not as magically different on the infrastructure side as like some people would have you believe. You can actually, training, you often need some bespoke stuff, but inference, you just need a server with a lot of GPUs in it. And depending on
you can get those GPUs.
Yeah, it helps. This is a case where we're big enough that we have relationships, like we can usually get them. It might not be as fast as I can buy like a CPU server, but it's still reasonable.
Right.
That may not be true if you're a smaller firm, but one of the benefits, we have vendor relationships. But yeah, building it up, we bought big GPU pools in North America. I put one in Europe. I put one in Asia. And then we initially had a hub per continent, basically. And then we had some customer feedback like, hey, like Europe's great, but we're the UK now. We want some GPUs just in the UK. Or, hey, Canada's great, but we want like American soil as opposed to North America. So we're probably 6 or 7 GPU hubs now. But it's, a couple of thousand hosts with GPUs in them right now, which sounds like a big number, but, compared to like the number of hosts Amazon has running GPUs, or, it's a drop in the bucket. But it works, and it lets us run our customers locally. And we give a lot of detail here. We generally run most of our LLMs internally. So we have our own internally developed LLMs. They're usually based off open source, but we do our own sub-training. We do, in some use cases, use third-party LLMs. Like absolutely, if you run our out-of-box products, there'll be some cases where it's like, oh, this is OpenAI, or this is Claude, or this is Gemini Flash. And as a customer, you can usually pick. You like, I really, I don't like Now LLM. I want to use Claude for everything. Okay, you can do that in a configuration page. But the defaults right now, we usually pick Now LLM because it's the fastest one. It runs right in the data center. But there's some cases where like, third-party ones work better. So we picked that. That works for the customer. And that's what we're solving for.
Interesting. You're hinting at I forget the name right now, April models that you launched a few months ago, right? Together with NVIDIA, I think, is kind of a partner for that.
And if you're really in the weeds, April, it's actually a child of Mixtral. If you remember, that was mostly a French model that came out a while ago. It was open source, so you could take it and train on top of it. And so instead of building a base model, we just took that, and then we and NVIDIA, because they're involved here as well, we did a lot of training on top of it to improve its ability to do complex reasoning. And our goal with April, it's a small model. It's a $15 billion parameter model. So it's not like a foundation model size, like with a trillion parameters. But our goal is we wanted a small, fast model that could handle reasoning tasks as well as most of the big models, even if as a consequence, it wasn't as good at some other like text processing tasks. We wanted a specialist small reasoning model. And I think we did pretty well with April. That's really what its sweet spot is. So if you put it in thinking mode and let it just grind away on things, you get good outcomes. And that's sort of that's the first way to put this. That's the tension you see if you're building applications on LLMs these days. Like the really big, beefy foundation models, they can do almost everything, often slowly, because it's such a big model. It just takes a long time for them to do it. So you're like, man, I got a great outcome with GPT, but it took 37 seconds to get there. And a lot of times you're like, all right, if this is a synchronous activity, let me look at maybe a smaller, faster model and a little bit of a different prompt. Can I get an acceptable outcome there? So finding that right balance between, where you want to be on the complexity stack and picking the fastest model that works for you is a lot of where the art is, rather than, I'll call it the science. Because like from a science standpoint, if you always pick the biggest foundation model, you'll almost always do fine. But it's not always going to give you acceptable performance or the happiest customers for a variety of reasons.
That's fascinating to me, because you're talking about the models, but then the models have to work within your infrastructure. And we write about, we covered the Kubernetes space since its beginning, right? We write about, before that, we were writing about containers, and the whole concept of orchestration has really emerged over the past 10, 15 years. And I'm curious about that intersection of, Linux distributions and AI agentic stacks, and how that creates, these different convergence points. If we're going deep, I thought I'd try to see if that might be something you need. Like, is it containers and orchestration that's the complexity? Is it the hardware abstraction? Is it the package management? I'm curious about what is the, there must be all kinds of conversations around these points.
Yeah, I'll be honest, like I don't want to sound glib about this. I have not, my team has not found the deployment and running of AI models to be super complicated or super far away from stuff we already did. And I'll tell you how it's strung together behind the scenes in ServiceNow. There's nothing secret about this. But in ServiceNow, it's a multi-instance architecture. So broadly, every customer production is its own unique software stack. Some are really big, if you're AT&T, some are quite a bit smaller. Like if you're, Owl Shoe Store, it's much smaller, but it's the same software stack, just scaled differently. More JVMs in the cluster, bigger database, more CPUs allocated, you get more stuff done. When you actually want to do something agentic, so I'll pick a really basic one. If you want to draft an email for you, and in the instance, you say, please draft an email for me. Your ServiceNow, that goes from your browser to the ServiceNow instance. The ServiceNow instance actually then talks to a little K8 service, a Kubernetes service that is basically the LLM router. And it says, hey, I'm such and such an instance. I want to summarize this email. Basically it tells the whole prompt in it, do something. That then, based on some metadata, says, oh, well, that one's supposed to go to this April model over here. And then I've got a different set of K8 services that are basically running Triton. And then the Triton services, actually, they literally have connections to the underlying LLMs. And at the Triton service level, you actually allocate, like, I want 53 is a bad number. I want 64 GPUs. We'll take a power of 2 associated with April. So you get sent over to that pool of LLMs running April. And at that point, it's sort of Triton takes over, like which specific one it wants to send you to, grinds away, flows back through, and you get your answer back. And based on how many tokens you get back, it could be really fast or it could take a little longer. It's just more tokens take more time. It's not that, like, we were already a K8 shop for almost all of our services. And this is one case we're lucky. We actually had some Triton expertise internally before it was cool. So when we actually decided to do this, it wasn't like, oh my God, this is some technology we've never seen before. The only thing that was new is I had to buy some gear from our hardware vendor that was like drawing a lot more power. So if you go into my data centers right now, they're not cooled to run rack after rack after rack of GPUs.
Mm-hmm.
So a lot of you call them blanks in the data center. I've got a whole rack of GPUs and I got an empty rack next to it. But that way I can run all the cooling air through the rack of GPUs in it, and it does fine. They're just not that funky. For training, it gets funky because you want like a big cluster with interconnects, and you tend to get bespoke for training. We did build a big training cluster, although these days we also buy training time from the usual suspects in the industry who sell you training. So,
but
that's interesting because that gets. I'm sorry, Frederick.
Go for it.
You go ahead. You go ahead.
No, I was just thinking you must have done the ROI calculations there to decide whether it's still worth buying versus building, I guess, for those clusters then.
Yeah, that's a big part of it. And then there's, we're, supposed to put this, finance cares about whether you've got capital tied up as well, or whether it's bespoke. There's a whole bunch of modeling that goes into it. It's not always based just purely on what's the cheapest thing. It can also be based on what gives them the flexibility, what's the best relationship. But there's a gestalt that goes into that ROI.
Sure.
Yeah.
Are you, sorry, Alex, I keep talking over you, but just out of curiosity, because it's been a while since the April models came out. Are you still training models? Is that still something you're
we doing? Are. I think the latest run I looked at was actually aimed at adding more Japanese language tokens to one of our models, so it was a little better at Japanese. And they probably are working on like a full. We got April. I don't know if they have May, but whatever's coming up next. But actually, I don't know what next full-on model they're coming out with. But they do. I mean, we do continue to do primary model development. Although I want to caveat that a little. We almost always take open source and then train on top of it.
Right.
The last model we did a true ground up on was something called StarCoder, and that was like 2 years ago. It was like a little bit before ChatGPT.
Back to you, Alex.
Oh, I was just curious. Sorry. I was just curious about the Kubernetes infrastructure that you're running. Is yours homegrown? And how are you managing GPUs on your Kubernetes clusters? Because I know that it can be a little fickle sometimes, where, like, for instance, the training can get interrupted.
Oh, okay. Yeah. So I give you two answers to that. So our K8 infrastructure, it's in our data centers. We run it ourselves. It's not based on like, OpenStack or something. Absolutely nothing against it. It's just like we wanted something like portable. So we have our own, it's called snow skates. Like we got our own operators. It's the right operators to mount like our storage and like our stuff. So if you're running a snow skate service, there should be no impedance mismatch. Like it just runs, and it runs the same in all my data centers. Whether that data center is like a physical DC I built, or whether it's like a hyperscaler DC, which is logically on Azure or AWS or GCP, Snowskates is the same. So like we abstract away like, okay, maybe I'm mounting S3 on Amazon, but it's Azure Block Store over here. It's whatever Google calls their version, but you get the idea. So Snowskates is consistent. And for training, for inference, we don't see a lot of GPU faults. And if you do, you can just rerun it. On training, that's where you see it, because you have a big training run, which notionally takes a week. And you're like, man, let's go. And like 2 days into it, some of your GPUs drop off. You're actually done. Like you're cooked.
Yeah.
And when you've got a cluster of like 512 GPUs, like we do for our like main training cluster, like one of them dies, your training run's dead. So at least what we do, I think what everybody does, is you just put a lot of checkpoints in there. You do not say run for 7 days. You fire it up and say run for an hour and checkpoint, then for the next hour. And then you try to set your checkpoint time small enough that most of a checkpoint succeed. And then if you lose 3 GPUs, like, okay, those drop out of the cluster, rerun it with 509 GPUs. And in the meantime, we'll call the hardware guys and they'll go in there and see what they can do. And I don't know, it's sort of knowable, but I don't know what percentage of our runs fail and have to re-go from the checkpoints. But that is the approach people use, is you just checkpoint and restart. Because at large training clusters, you're going to lose there's a mortality rate in these things. I mean, they're super hot and they run close to the technical limits of the silicon.
Is that a hard problem to solve from a software viewpoint in terms of creating more resiliency in those clusters to be able to do them training effectively?
It hasn't been something that's been impossible. And I think we have the advantage of like, we're not the only people in the industry doing this.
Right.
So if you can talk to your peers and like, hey, what are you doing? Hey, we just checkpoint and restart. Hey, we're doing the same thing. It's not like we're, that part's not primary research. It's just sort of defensive software engineering. I think the problem, which is harder, ideally you'd want to not have to do that. You'd want to have the cluster itself be redundant to the mortality, some amount of mortality rate within the cluster. You know, it's like storage arrays, you allocate some dead blocks and the storage array like transparently routes around it. You don't have to like rebuild your storage every time something falls out of the RAID array. That one seems harder. Like that one, I just don't think people have solved yet. The current state of the art is like checkpoint and restart. I do think some smart human being probably working for like one of the people who makes chips for a living or the software on top of it is going to come up and be like, hey, we finally solved it. Like, you don't have to, well, it's like the RAID array of GPUs. You allocate 10% extra and we don't restart on death as much. But that one's unsolved to my knowledge right now.
Yeah, somebody this week told me that, you know, uptime for a GPU cluster isn't measured in nines, but maybe 90.
Yeah. It's like, it's also how you define it. Like my team's like quotes the same thing, but I'm like, but the cluster doesn't go down. Like, no, but we lose a few things in the cluster. I'm like, okay, that's a really nuanced point.
It just seems like there's something lacking there. And it seems, and I keep wondering, will Genic AI come to the cluster itself?
Well, like I was talking, like, APRL is actually what we use for a lot of our agentic reasoning. So like if you invoke some of ServiceNow's agentic stuff, it is literally an APRL model on the inference side, which does some of the reasoning. Sometimes it's not, sometimes it's other models, but sometimes it's absolutely APRL. And so that one is running in our data centers on our clusters. And APRL is a small model. It literally will run fine on one GPU. The limiting factor on model density tends to be memory footprint, and like a $15 billion parameter model will run quite happily on, you know, an H100, several copies on there, and it's just fine. The bigger the models are, the more memory they consume, and then the less copies you can run per GPU. And the really big ones, they span multiple GPUs, and then you run into a limit of like the hosts I buy, I typically buy an eight GPU host. So if my model fits on less than or equal to 8 GPUs, it runs well on that host. If it needs greater than 8 GPUs to run, I got to get a bigger host. And so that, fortunately, nothing we run's that big. But if I wanted to run, you know, OpenAI, GPT-5 need more than 8. So somewhere inside a Microsoft Azure data center, there is a really big box with a lot of GPUs doing that inference. Or they've got memory interconnects on the back end, which is another way you can solve it.
Maybe to level up the discussion again.
Yeah.
Maybe.
I did say I could go deep. So.
No, totally. No. Bit jarring segue, I think. But I really want to talk about the release today as well of Zurich, the Zurich release of ServiceNow today, where you're launching kind of the vibe coding part for the developers on top of ServiceNow, not internally. And then we've got an audience question.
We got an audience question,
which is very nice. But we'll get to that in a second. I really want to touch upon kind of the build agent, I think you call it, for vibe coding ServiceNow based applications, basically.
Yeah, so ServiceNow, and like this is broadly true of most enterprise software these days, but for us it's like strongly true. ServiceNow product is a metadata processing engine. Like when ServiceNow boots up, like it doesn't know anything except, hey, look, there's a database you can connect to, and assume that there's a table called dictionary and like extrapolate from there. And then inside that database is all the metadata about your instance. Like here's the logo that's going to go in the top left corner. Like here's the way you want the home screen laid out. Like here's the way emails should be formatted. Everything you can think of that defines the behaviors of your instance, it's some form of metadata in the ServiceNow world. and it's, you know, the same things broadly too in Salesforce, same things broadly true if you go to Workday. Like that's just the way enterprise software works. It's a lot of metadata. Like this is the form metadata, this is the business rule metadata, this is the email template metadata. And if you know the system well, you just know how to hunt and peck your way around. I'll do this, I'll do that, I'll do everything. And there's tools we give you. There's like an IDE, which hopefully finds these things for you, and you know, one click away, but it's still a lot. And so it's also a really good use case for AI coding assistants. So you don't have to say like, hey, you know, I want to build I don't know, I want to build a business rule which updates SAP every time the purchase order gets approved. Yeah, you can do that. You can type it in and it'll absolutely work. Or you can bring up Build Assistant and you can say, hey, please, you know, set something up which does this for this, or which actually updates SAP. You got to be a little more than that. You got to say, hey, every time this ticket gets this approval gets approved, please put the matching purchase order over in my production SAP cluster. And you hit enter. And then it will do its darndest to write the appropriate business rule logic there for you. And it's like any coding assistant. It's probably not like, oh, it wrote some code, push it to prod without looking at it. There's definitely like, okay, maybe it had a bug in it. I should probably test it. Like there's still the human in the loop, strongly human in the loop. But you can iterate on it using the prompt as well. Like you can iterate by like, okay, the prompt started, wrote some code, I typed in the code, or you can like adjust your prompt, say, that's not quite right. You know, I wanted to do it only if the purchase order is greater than $100. You can put that in and it'll, you know, iterate the business rule and you can try it out again. And it's not just business rules. There's a bunch of parts of metadata, like it'll write a playbook for you. It'll do something called a flow designer flow. I think if you try hard enough, you can try to talk it through making a form for you, but it's like the wrong paradigm. Like chat interface is not the right way to define a visual UI. My point of view, although my designers tell me they can do cool stuff with some stuff like that. But what's I going to say here? The goal with all of this stuff is we will make it easier for people to turn our stuff on and configure it and get live. That's the tailwind of all this AI stuff is it's like, people are like, man, like it's making us more productive. We want to do more with software. We want to deploy more technology in our company. It's a great tailwind. The headwind is it's like putting a huge demand on like people who know how to deploy stuff. It's like, man, there's like way more software people want to get out there and it's some new stuff. And like, so anything we as a vendor can do, which is going to help our customers get live faster, or configure stuff faster, or write new stuff faster, basically use our stuff to get value. It's like nearly the top of the peg on our product roadmaps right now is we want to get our customers to value as fast as we can.
It's interesting you say configure, you configure it, and that configuration is so important, you know, obviously to you and to your customers. How do you view configuration and how it's evolving?
Give a nuanced answer. So I entered the industry, like configuration is like a systems programmer. Like you got out some assembly code and you coded.
Yeah.
And then at some point it became, hey, look, I'm going to configure an out-of-box application. You know, I bought, you know, Vantiv, and like you would configure Vantiv with this like called Van Basic. It was a basic and you wrote some code. But it was usually a programmery job, and it was usually in some form of a vendor-specific language, or like maybe the grammar was well understood, but it was very vendor-specific API and stuff like that. Over time, like ServiceNow still has that vendor-specific concept, but it's JavaScript, so it's a well-understood language. But a lot of the metadata got extracted out of code. So it's no longer like algorithmic code which generates the form. There's a separate set of metadata which is like, this is a form definition in metadata, or this is the metadata that defines an integration to SAP. And that in a lot of ways simplified, because like code, and you got to have a certain brain to think algorithmically, like I do. So it's like, well, of course, but I'm a terrible artist and a terrible musician. Like my brother's like, how can you not see that that's out of tune? And I'm like, I can't see. he's that weird freak of nature, but he's good at music and he's also good at technology.
That's cool.
Yeah, he did get both of the genes. I guess the point I'm making is like, as the metadata got broader and more robust, it probably is the wrong word. It did get simpler. Like, you didn't need to be a CS or a double E to fill in the metadata. It was less algorithmic. But the breadth of the problem space started to expand.
Yeah.
So oddly enough, we replaced a complexity problem with a knowledge problem. Like, you got to know more stuff. And as an industry, I think we are adding to that with all the AI stuff as well, because it's like, okay, everything you had to know, you still need to know that. And there's this other metadata defining how the models work. Oh, and by the way, if you really want to, there's this prompt over here, which is kind of the AI equivalent of banging out some code, which is not that easy. It's like, it's easy. It looks easy on paper. It's hard to get it right. So we're definitely trying to trim that knowledge requirement back down. That'll be hard. Like, I don't expect that like this time a month from now, we'll be like, whoop, it's solved. Like, my mom can successfully deploy enterprise software. But that is like definitely an area of focus. It's not just me, like other people in the industry are focusing on the same thing, because we're selling a lot of this stuff and we got to get customers to value on it. And the customers are demanding it, like totally fair. Like, you're paying us some money. I got to get you live and I got to get you to value. That's just the way that this business works.
Frederick, I want to hear the question.
Yeah, and it's actually tangentially at least related to what we've just been talking about. And the question, Pat and I, we talked about this in the past, is how have LLMs impacted the hiring of interns and junior developers at ServiceNow? It's a question I think a lot of people have on their mind. And if anybody else has more questions, just ask them as well on YouTube.
Yeah, I'll give an imperfect answer. So last year we still hired a lot of interns. I think remember, I just looked at this. It's like 160 interns that we hired, not as interns. Like, you were a former intern and we said, we loved you as an intern. We would like you to join here full time. I think it's about 160 people worldwide in this calendar year. So we are definitely still pipelining interns in, and we're definitely still pipelining junior developers in. Having said that, it is, I think, a little less than we did the year before. And the discussion we've had is, if you look at where the AI coding tool's sweet spot is today, one sweet spot is like a self-contained like microservice that you can really describe completely in a prompt. They're actually really good at that. The other thing is, I'll call it basic low complexity engineering tasks that don't require a lot of code-based knowledge. And those low complexity tasks tend to be what you get junior developers to do, because it's like, that's what they're good. The senior developers probably aren't going to do a better job on it because they'll get bored with it. And if you're a junior developer, I probably can't ask you to do something which requires incredibly deep, like, hey, refactor the cache manager. Probably a bad idea. You don't know the code base well enough to do that. But that's part of your career progression. You've learned algorithms in school. You go through like your junior developer phase where you're learning the code base. You're maybe learning how to operate in a corporate environment with, rules around pushes and pulls and testing. And then you come out the other side and you're like, okay, you can work more independently now. I can give you more complex tasks. We haven't yet seen like a real crash is maybe the wrong word, it's too aggressive. We haven't really seen like a super strong reduction in the number of junior people we are hiring. But I do think industry-wide, that is the most at-risk sector of the tech stack. Like, who is like most likely to see a reduction in demand? I would say it's that junior engineering level right now, because it's the most overlapping with the stuff I can do right now. So like, I've got a daughter, she's at TCU, she's a mechanical engineering not graduate, she's a sophomore, she hasn't graduated yet. But she's asking me, hey, like, I kind of like technology, but I'm kind of bored with it. And mechanical seems more fun. And I'm like, well, do what works for you. In the back of my mind, though, I was thinking, like, if she said, like, I'm really passionate about CS, like, I want to switch into CS, I'm not sure what my advice would have been. I think I probably still would have told her to do it if that's your passion. But like 5 years ago, I would have said, like, man, like, you can't go wrong with CS or double E. Right now, I think it's more nuanced. I wouldn't stay out of it, but like, it's not like a no-brainer choice. I think the industry is definitely being disrupted is the right word. So I'm sorry, I think you may be muted.
I think Alex is muted there. We've lost him.
Well, I like your advice. And you know, mechanical engineering is fascinating too, right?
And
and like that's going to all be affected by AI as well.
It is, I think, in different ways. But I think that's the ground truth of this. Like this is a technology revolution. It's probably going to be at least as big as the internet revolution, and it's gonna disrupt a lot of things we do today. And you know, I sincerely believe like the net out of all of that disruption is going to be very positive for humanity. You know, we're going to produce more goods, more services, a better quality of life. All these things are true. But it doesn't mean the transition is just going to magically happen. Like we're going to have to work through it. And we are the we. Like, it's not like someone else is going to do the hard work here and then we're just going to come out the other side. Like, we're going to do the work, we're going to manage the disruptions, and we're going to make the choices. The choices we make every day are going to impact like where this technology evolves to. And to some extent, you know, what society looks like, you know, 5 years from now or 10 years from now. And I'm a technology optimist, so I think we're going to make generally good choices, and it's going to be good for the aggregate. But somewhere along the way, some human being is going to make a bad choice, or we're going to make a mistake somewhere. But that's just the nature of these evolutions. The positive side of that, it's a lot more interesting to deal with one of these technology changes than to just be in a steady state world. So if you take intellectual pleasure in hard problems and working through things and kind of figuring out how to solve problems that have not been solved before, I do think this is a great time to be in technology.
Well, on that positive note, I think it's probably a good spot to end. Alex, any last words from you?
No, I just thank you so much for your insightful responses. I have about 50 more questions, but we'll hopefully get a chance to talk again.
We'll do that next week then. But actually next week, talking about Windsurf, next week on the show, we've got Cursor and Linear.
Awesome. So they're all good products. Like I picked Windsurf. I don't want to say anything bad about any other competitors either.
Yeah, no problem.
Particular use case they want.
Oh, for sure. For sure. It's a really interesting time to be in that space, and all that might change again in 2 months anyway. So
it's 6 months from now, there may be a new kid on the block who's better than everybody.
Exactly. Awesome. Well, thank you, Pat. Much appreciated.
Well, thank you. It was a pleasure talking to you both. And hopefully your audience enjoyed it as well.
Yeah, thanks a lot.
For sure. Thank you.